Let's focus on covalent bonds now. Uh, Covalently bonded molecules are typically just nonmetals bonding with each other by sharing electrons. And this makes up a lot of the chemistry that makes up us as a living organism and also other living organisms like plants. We call this field of chemistry where we're looking at primarily covalently bonded molecules as organic chemistry. And these are all molecules that'll really be based on carbon and hydrogen and oxygen. But you also see a lot of nitrogen, sulfur, phosphorus, things like that. But carbon is kind of the defining factor of what is organic chemistry versus inorganic chemistry. So let's look at the covalent bond itself. So we keep saying it's sharing of electrons. And what we mean is that two atoms come together and they don't have enough outer electrons to have an octet or to feel like a noble gas. Remember, our noble gases are all the way on the right hand side of the periodic table, and they have a filled shell or a complete set of outer electrons. And that lends a lot of stability to the element or the atom. It doesn't like our noble gases don't really react with much. They just kind of do their own thing. They're like, we call them inert. And so as atoms form molecules, they are sharing electrons to try to have that same at least configuration of electrons that a noble gas has that's so stable, even if their protons don't match. And so And so the sharing of the electron between them means that we'll have two electrons, one contributed from each atom. So here are our two hydrogen atoms coming together. And as they move together, these two electrons that they each contribute into our covalent bond are going to be shared between the two atoms. And what that really means is that each of these electrons are attracted to the nuclei of both of the atoms. And so the hydrogen atom or nucleus experiences an attraction to just one electron when it's alone. And once it's in that covalent bond, it experiences an attraction to two electrons, one that it was attracted to before and one that came from the other atom. And these electrons then spend time around both of the nuclei that are sharing the electrons. And you can find it closer to one or closer to the other. And so we tend to draw the electron clouds as kind of like these ovals encapsulating the two atoms. So a few details about this. Here's another example of hydrogen and fluorine forming a bond together. Hydrogen is our simplest element, right? It's just one proton, one electron, not even some neutrons. And so it's an exception to the octet rule. It's so small that it actually can't fit 8 electrons around that one little proton. Helium's the same. It's also really small. It's 2 protons and 2 neutrons. And both of those elements will only have 2 outer electrons. It won't have 8. Now, all the elements below it on the periodic table will be able to have up to 8 outer electrons. Sorry if I said valence. So keep that in mind. When we're looking at hydrogen, it's trying to follow the duet rule, right? So it wants 2. Everything else is going to go for 8 outer electrons. So when our atoms covalently bond together, and let's say we have fluorine and hydrogen, and fluorine has 7 outer electrons, and here is its electron dot symbol. It almost has an octet. It just needs to share with another element to pretend it has one more electron. If it was an ion, it would be -1. It's going to form one covalent bond. And let's say it forms that bond with a hydrogen. Just like before, they're both going to contribute 1 electron into the shared bond. And so it's like this one right here is coming in and this one from hydrogen. And they're forming this shared set of 2 electrons right there. We usually represent it as drawing the two dots in between the two element symbols. And those make up the covalent bond, which we can represent as two electrons as dots, or we can represent it as a line. So it's actually. So when you look at a structure and you see a line, those lines each represent two electrons. Fluorine had 6 other electrons, though, so it's only sharing one of its electrons with its hydrogen because hydrogen can't fit all those other ones around it anyway. And so we have a set of what we call lone pairs. They're right here. These are the other electrons that are in the outer sphere of fluorine, and they don't participate in the covalent bond. If they're not sharing, we call them lone pair electrons, or non-bonding electrons is another way you'll see it written. And we still include them because it helps us track that we've reached our octet. And we just kind of write them as paired dots around our electron dot symbol. So now we're going to next walk through how to build these, or like decide how things are connected together and represent things as Lewis dot structures. But this is kind of our foundation of like how we're going to think about covalent bonds and how we think about the sharing, and a little bit into how we're going to represent that on paper.